Hello everyone, welcome to this session. In the last session, we talked about the MATLAB GA function. So in this session, we will use this function to solve a mathematical benchmark problem. First of all, let's review the mathematical benchmark problems. So these are problems that are used to test the performance of the algorithm before using it for an engineering problem. So these problems have various characteristics. Some are unimodal, some are multimodal, and we have different shapes and number of variables. Often for these problems, the global optimum or the Pareto front is known beforehand. So we can see that if our result obtained by an algorithm is good or not. These functions are cheap enough because they are the analytical functions and we don't need any simulation. The computation is very fast. Also, there are many reference performance in the literature of various kinds of algorithms, and you can compare your result with them. So these are the general information about the mathematical benchmark problems. So here I provide 3 hyperlinks. So when you click them, you can find more about the widely used benchmark problems. Then the pros and cons of them. A first benefit is that they can provide a quick evaluation of an algorithm to see if it's okay or not, right? So if you find a relatively easy benchmark problem, but your algorithm doesn't work, so you might need to first see what happened before using it to an engineering problem, right? And also in these benchmark problems, there are some kinds of shapes and characteristics that are similar to some particular engineering problems. So they can be used as a reference. But however, that these benchmark problems are not generated from engineering problems, so we can't use them to rank the algorithms for engineering applications. So for example, when you use a benchmark problem and we found the algorithm A is better than algorithm B. But when we use it to an engineering problem, the result may be opposite. So we can't use a benchmark problem to rank them. Okay, and in this session, we will use a benchmark function, the Rust reading function. We have seen it before, right? So here is a formula. And this function has many local minimum, as I have shown in the previous figure, but there's only one global minimum. So global minimum are all zeros, and the corresponding function value is 0 as well. So you can see more details in the live script. Then we will use GA to solve this function, to solve this problem. Let's first use the simplest form. X is output, GA, parenthesis, at, we call it Rust R underscore fx, comma 2 means 2 variables, right? So this is a function handle. So there's a function, we want to call this function as a variable, we use function handle, right? So this RNG default, this means because GA, we need random variables. So this one, we set the same seed, so it means each GA use the same set of random variables so as to compare them. So when I use this function, we can see this is the result. The obtained X is 0.97, 0.94. We know the global optimum is 0 and 0, right? So this has some distance. So we can see it's here, and the solution has some distance to the true optimum. So more details you can see in the live script, and you can write yourself. Then we use a search bound. So we can see the search bound is set here. So these 4 empty square brackets, they are for the constraints, inequality, the linear, the equality and the inequality constraints, right? So because there's no constraint for this function, so they are empty. So here I provide the lower bound and the upper bound of the 2 variables. So each of them from -5 to +5. And let's see what happened when we use this command. Then we can see this is the result. Notice there is a 10 to the power of -5. So we can see this is quite near the global optimum here. So very near to the true minimum. You can write yourself, see the live script. Next step, we add the options. So we use optimal options to set the plotting to GA, and I put these options to here. So after run this one, we can find the solution is very near to the true minimum, and the convergence curve is plotted here. So we can see the best fitness and the average fitness of each generation in the GA optimization process is plotted here. So we can see it here. You can also write yourself using live script. Then this time I added a y here. So what is this? This is the int count, right? So I'm saying the first variable should be an integer. And I also expand the search range from +5 to +1,500, and I put all this here. So then we can see that this is the result. As you can see, this is nearly 0, and this is very small. So this is a solution is very clear to the true optimum, and we can also see the plot here. Right. So you can also write yourself using the live script. At last, I put two output, including the x and its function value FVL. So we can see this is the output. Not only x is here, the FVL is also here. Right. So the solution is very near, and this is a plot. Okay, so now in this session, we use a GA function to solve a mathematical benchmark function, the two-dimensional Russell region function. And in the next session, we will solve the real-world engineering case studies. Okay, thank you very much. Bye-bye.